Hello to all space lovers! Today, we are going to solve one of the most interesting and often asked riddles about the Moon: why it is always turned to the Earth one side. This phenomenon is familiar to everyone who has looked at the Moon at least once. We always see the same side of it, no matter where, and when we observe it in the sky. But how is this possible? What makes the Moon behave in such an unusual way? To answer this question, we need to delve into the physics of planetary and satellite motion, as well as the history of the formation of our solar system. To understand why the Moon is always turned to one side of the Earth, let's start with its origin. About 4.5 billion years ago, the Moon was formed by a colossal collision between Earth and a Mars-sized planet that scientists call Theia. This collision threw a huge amount of debris into orbit around the Earth, and over millions of years, this debris coalesced into what we call the Moon today. Since its formation, the Moon, like all celestial bodies, has rotated on its axis. But over billions of years, its rotation was slowed by the gravitational influence of the Earth. It is this slowing down that has put the Moon in what is known as a state of synchronous rotation. Synchronous rotation is a phenomenon in which the period of rotation of an object around its axis is equal to the period of its revolution around another object. In our case, the Moon makes one complete revolution around its axis in the same amount of time it circles the Earth, about 27.3 Earth days. This is why we always see the same side of the Moon. This is not a unique phenomenon in space. Many satellites of planets in the solar system, such as the satellites of Jupiter and Saturn, are also in a state of synchronized rotation with their planets. But what causes the Moon to slow down its rotation and stop on the same phase in relation to the Earth? The answer lies in the gravitational interaction between the Earth and the Moon. The Earth, being much larger and more massive, exerts a strong gravitational influence on the Moon. This interaction causes what are called tides and ebbs in the Moon's interior, just as the Moon causes the oceans on Earth to ebb and flow. When the Moon was spinning faster, its shape was slightly elongated because of Earth's tidal forces. Earth's gravity was constantly pulling on this elongated part of the Moon, trying to straighten it out. Over time, this gravitational friction slowed the Moon's rotation until it coincided with its orbital motion. At this state, the gravitational tide stabilized and the Moon froze in its position. It now always points one way to the Earth. Perhaps the question arises, if the Moon is always turned to the Earth on one side, does that mean it does not rotate on its axis? The answer is no. The Moon does rotate on its axis. It just does so at the same rate that it rotates around the Earth. If the Moon were not rotating, we would see all sides of it as it orbits the Earth. However, due to synchronized rotation, it remains looking one side. Another interesting phenomenon associated with the synchronous rotation of the Moon is its so-called far or back side. Many people mistakenly call it the dark side, but it is not. The far side of the Moon receives as much sunlight as the side we see. However, because of its synchronized rotation, people from Earth never see this back side. It has only been explored by spacecraft. The first spacecraft to film the backside of the Moon was the Soviet Luna 3 in 1959. Today, the backside of the Moon is being studied in much greater detail. And in the future, it could be a place for scientific bases because there is less radio interference from Earth, making it an ideal place for space observatories. Although the Moon seems constant and stable to us, its orbit is slowly changing. Each year, the Moon moves away from the Earth by 3.8 centimeters. This is because tidal forces between the Earth and the Moon transfer some of the orbital energy from the Moon to the Earth, slowing our planet's rotation and increasing the radius of the Moon's orbit. Over time, this may lead to the Earth and Moon reaching another amazing state. Their days and years will become equal, and both planets will always be turned to the same side of each other. Now let's talk about what we see on the visible side of the Moon. This lunar landscape includes large dark areas that are called seas, although they are actually giant ancient lava plains. The Moon's seas were formed after asteroid impacts, when liquid magma rose to the surface through cracks in the crust. In addition, Numerous craters can be seen on the Moon, which were created by comet and asteroid impacts over billions of years. These details on the visible side of the Moon are what make it so recognizable to us. This is the side that humans have always seen from Earth, and it is the side on which the Apollo mission astronauts landed in 1969. So, now you know why the Moon is always turned to one side of the Earth. This is the result of billions of years of gravitational interaction between the Earth and the Moon, resulting in a synchronized rotation. Even though we always see the same side of the Moon, its backside remains just as important an object of study for us. Don't forget that our cosmic neighborhood is full of mysteries, and the Moon is just one of the many wonders that continue to inspire scientists and astronomers around the world. If you enjoyed this video, don't forget to subscribe to the channel, give it a like and click on the bell so you don't miss new exciting episodes about space. Thanks for watching, and see you soon!